Assalamualaikum and hello. My final year project title is Whirling frequency for an automotive drive shaft. I used to remember about tick 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 sound. This sound come out from cars or other vehicle. This sound become more louder and noise and can make your car or vehicle broken. This tick 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 sound is because of the drive shaft. A shaft is an important rotating machine element which is responsible for transmitting the power generated for a source to a required part. For automotive drive shaft, the function is to transfer the engine torque from the gearbox or the differential to the wheels. Drive shaft used in many vehicles like cars, bus, truck, and others vehicle. This drive shaft is a solid shaft as well as a hollow shaft. Automotive drive shaft is different from other shaft because this shaft is comparatively short and it comes with limited space. They are made solid to provide a clearance for movement of the suspension, and otherwise the lightweight turbulent section is often used. Such rotating equipment that operate at high speed has been used in a wide range of industrial applications like textile, automotive, and electrical spindle. Okay, an important type of vibration that need to be controlled is the lateral vibration, or which is called whirling. Can you all imagine when a drive shaft whirls and reach to the natural frequency? Do you know what will happen? Whirling is a phenomena where the plane of the enclosed beat-up shaft axis and the bearing center line rotate about the bearing center line. This will cause the shaft to bow out as illustrated. This condition can occur due to the mass imbalance of the shaft or disc, and it also occurs at resonance, where whirling natural frequency is equal to the spin speed. That is, I said for the before slide, this will happen. This speed of the shaft at resonance is called as a critical speed. So, because of this drive shaft problem, I got a chance to do a research about this drive shaft that is more complicated shaft compared to other shaft. For this research method that I use is model analysis. Model analysis is used to determine the vibration characteristics such as natural frequency and mode shape of the drive shaft. The rotational speed is limited by lateral stability consideration. Most designs are subcritical, that is, rotational speed must be lower than the first natural bending frequency of the shaft. The natural frequency depends on the diameter of the shaft, the thickness of the hollow shaft, and the specific stiffness and the length of the shaft. Lewin and Dermin apply 3-nodal Tymoshenko beam finish element to model the investigate natural whirling speed of rotational shaft with various end condition and slitness ratios. Okay, next slide. In this research, we conduct 2 simulations. First is preliminary and second is parametric studies. For preliminary study, I use simple shaft for a simulation. Why? Because the objective for this preliminary study is to compare the result with the complicated shaft result later. Also, the result obtained here are firstly to warranted to be the converged values and further validated with the result from previous study to ensure that the results are reliable. This preliminary study is to find the natural frequency, the critical speed, the camber diagram, also the mode shape. Okay, for the element that I use for this study is beam 1 and 8 as the main element, and the both and at the both of end shaft I put a fixed support. Next, for the parametric study, this study was conducted by using Ansys Workbench. Parametric study for this research is to study the effect of natural frequency by changing the length and diameter of the drive shaft. How I model the drive shaft? I model the drive shaft by using SolidWorks. Then I export it to Ansys Workbench. So in Ansys Workbench, I need to complete a few steps to get a data for natural frequency and the critical speed. The first step is I need to confirm my model in correct dimension. After that, I need to do a meshing in order to get an accurate result. Next, I apply a fixed support at both of the end of the shaft, and I apply the rotational velocity that I set, which is 0 rpm and 20,000 rpm at the shaft, and lastly I solve it. Okay, for the element that I use for model this drive shaft is solid 187. The material that I choose is steel, and their properties is like on the table. Okay, you can see from this table the Young modulus for the steel is 207 gigapascal, and the Poisson ratio is 0.3. The density is 7,600 kg per meter cube. The shear modulus is 80 gigapascal, and the last is the shear stress for the steel is 370 megapascal. So why I choose this steel as the material? This material very strong and has a toughness, and also suitable for the material for dry shaft. The result for parametric study is shown at the table in this slide. So the parametric that was changed is the length and the diameter. We set the length at 0.470 meter, 0.570 meter, and last at 0.670 meter. When do a simulation at Ansys Workbench, we set a 3 mode to get a data. Okay, from these two tables, we rotate at 0 rpm and 20,000 rpm. We need to compare the value of natural frequency. Okay, for these two tables, we can see at 0.470 meter, the natural frequency at both rpm are the highest natural frequency. So we can conclude that when the length of shaft shorter, the natural frequency will be increased. For the result of changing the diameter, we set the diameter at 0.03 meter, second at 0.04 meter, and last at 0.05 meter. We rotate at the same like we changing the length, we rotate at 0 and 20,000 rpm. So from this table, we can see when the diameter is 0.03, the three value from the three mode are the lowest one. So we can conclude that when changing the diameter at 0.05, the natural frequency will be increased. So when the diameter increase, the natural frequency will also increase. Last but not least, for the conclusion, the all objective was achieved by doing this research. It can be concluded when the diameter of the dry shaft increase, the natural frequency also increase. But for the length, when the length is increased, the value of natural frequency will be decreased. That's all from me. Thank you for lending your time.